Hi, bado unatumia Excel kufanya analysis? Kuja nikushow. Um, Python can help you do this work efficiently. Hebu angalia hapa. Hapa niko na data. Hapa niko na Excel file. It is already loaded into this Colab environment. Now, hapa nataka develop a model that I can use to predict this column. Now, this data is all about phishing website and legitimate websites. There are so many features of this data, like the domain length, is domain IP, and so many vitu mingi. Nataka kupredict whether this data nataka kujenga ama kufit various models that can be used to predict this. What are the steps? Ni steps gani mimi hutumia? Acha nikushow. The first thing ni kuimport various packages or libraries that I would want to use, and these are the packages. After that, I load the data. Now, the data itself is in iko kwa nishaiload kwa drive. So hapa ni kuicall. So the first thing is to load this, to load these models. It will take some time. Then after one, I call this library that inachukua data kutoka kwa drive into my system. So after that is data processing. Now you check. First thing I do ni kuangalia whether the data itself iko na any missing values, and this is how I do it. So luckily this data did not have any missing values. Now there are so many things that determines your accuracy of various models, whether the data itself is noisy, whether the data processing was done right, what was your data pipeline. There are so many things. So the first thing I did in this analysis is to check whether kuna duplicate URLs. You see, this data is all about URLs and website. So I wanted to check whether they are duplicates URLs. So I learned this code, and I got a total of these URLs. So the next thing is to remove the duplicates. Now, as I said, there are so many factors that contribute into the accuracy or the performance of your model. Now, under the data processing, you could do various things to clean your data so that when it is fed into the model, you are very sure the result will be valid and what you get will be good. Now, when I looked into this data, there are various columns that hold no predictive power. This includes this. So I had to remove them. Then all other conflicting labels, I had to remove them. So these falls under the data pre-processing. So another after data pre-processing, the next step is always descriptive analysis or explanatory analysis. So you can use various methods. I like using chunks that can do this analysis all at once. And this I used the for loop, and I declared various columns that was interested to me. I was very interested. So I could do these graphs, for that analysis, and this table to summarize various columns. So afterwards, then is to split the data. Remember, for this machine learning, you have to have the training and then the testing set. So the best way is to split this data. So in this case, I did not do the conventional way. So what I did, I first dropped the non-predictive columns. Then when these non-predictive columns are removed, then I also removed the target variable or the label variable, and I made sure that my target is to predict the phishing, and the phishing is labeled 0. So I had to make sure I declare this specifically for the model to do. Then, since the data itself is big, you can see here, you can see, well, yes, you can see here the counts are in, I think, 200,000. To train these, it will require a lot of time and a lot of resources. So what I did, I took a random sample of that, and the sample is around 60,000. This is the one that I will split into two, training and testing. Yes, and I made sure that the proportions of labels, that is zeros and ones, in the original data is maintained in this sample. So this is the code to do that. This is the code to do that. And you can see that it is actually maintained 57.5 and 42.5. And if you take these, if you look at these proportions here, sorry, where are they? These here, these are allowed 40, 42, and this 57 out of the total. So you can see my pipeline here maintained this. Now, another thing, I want, after training my model, I want to do cross-validation. Cross-validation is simply taking small portions of the data, train on them, test. Another one, test. You repeat that for a number of time, and my number of time here is 5, so that you compare the average or the aggregated. Is it similar to what the final model is? So this is the code I did for that. Now I did trainings. I did train 6 models. The first one is this, the decision tree, random forest, SVM, KNN, ANN, and naive Bayes. So, as I said, the further data pre-processing were imbued or embedded within the specific model pipeline. For instance, if you take the first model is decision tree, this is the pipeline. So I had to do this to select the best or the top 40 features that explain to this model. So, and I trained the model. Remember, I would first do the hyperparametric training. Yeah, the reason as to why hyperparametric training is needed. This is the parameter grid. Then you feed this into the model. Feed this into the model. Now, within the pipeline, this happens to each and every model, as you can see. And I was trying to get for each model, I was trying to get the best optimal parameters that were found. For instance, this is the parameter setup of the best optimal ANN. This is the parameter setup for the best naive Bayes. So after training, it's always good to compare the performance of this model. Now, there are so many performance metrics: accuracy, recall, precision. There is another one that is called phishing precision, specificity, F1 score, balance accurate. All this, and also the training time, testing time and hyperparametric time, the time it took to jog around various parameters until the best optimal parameters are obtained. That time, yes, you can compare them and display the best parameters. Then this is the comparison of the time. Tuning time, that is the time it took to think all over that parameter grid until you get the optimal one. The tuning time, the fitting time is the time now after getting the optimal parameter. Now you retrain that model using this parameter on that specific training data. Then testing time, it's the time after now getting the final model trained, you test it on unseen data. That is the time you compare it. And then, because this question was all about classification, the classification is always good to consider the confusion matrix. The confusion matrix also, there is theory behind this. What are the true positive? What are the true negative? What are the false positive? What are the false positive? For instance, in this case, remember, the aim is to predict phishing. Phishing is labeled 0 and legitimate are labeled 1. So these are the true positive. This one is the true negative. Then legitimate, which are predicted to be legitimate. Phishings, which are predicted to be phishing, are the true positive. Then this is the false negative. This is the legitimate one that were predicted to be the phishing website that were predicted to be legitimate. That is false. Positive, false, negative. False, negative. Now, the legitimate that were predicted to be positive or the phishing, this is the false positive of various models, decision tree, random forest, VM, all over until we get ANN. There are so many ways of doing this. Then this is a ROC curve for the model. Then you conduct. You remember the cross validation. You conduct it now here for 5 folds. Now these are the results. At fold 1, this at fold 1, where are they? No, yes. At fold 1, these are the results. At fold 2, at fold 3, at fold 4, these are the results. You can do this. Then there's various ways. I don't want to go beyond this. If you want to learn such, please hit my inbox and I can always guide you through how to do data analysis for this. Thank you.